Okay, so our next topic is numerical integration, and that's going to help us to be able to compute integrals that from what we defined are not integrable. So we're going to approximate the value of a definite integral by using the midpoint and trapezoidal rule, determine the absolute and relative error in the numerical integration technique, estimate the absolute and relative error using an error-bound formula, recognize when the midpoint and trapezoidal rules over or underestimate the true value of the integral, and then also learn Simpson's rule and do the same thing with the error. Okay, so here's an integral. All right, another integral. Okay, so that's x cubed, actually. It doesn't look like it, but that's x cubed. Okay, so these integrals, I have no idea. We don't know how to actually compute these integrals, but it would be nice if we could. All right, so sometimes we have integrals that are areas under the curve or integrals that appear in problems that we're solving or research, and we need to at least get an estimate for the integral. Okay, so by definition, we've always said that if we draw a picture, so I'm going to draw a picture here. I'm going to move it over just a wee bit. And if I take and draw a function, let's say it looks like this. Okay, so that's my function. All right. Okay. All right. So that's my curve. All right. I know that so let's call this f of x. So this is y is equal to f of x. So the integral I equal to the integral from a, oh, let me put in a and b of f of x dx by definition is what in relationship to that red curve? What does that integral represent? What is that integral by definition? Whoa, I hear crickets. Nobody knows the relationship between the integral and that function?
Is it the area under the curve?
Thank you very much. All right, this is equal to the area under the curve of f of x on the interval AB. So that's the area under the curve. Okay, so let's look at trying first. Okay, the midpoint rule. So that's what we're going to look at first. All right, so when we go to look at the midpoint rule, I'm going to put my picture back. If I just use this as one interval, so I'm going to let n equals 1, then the length of the interval AB, h, is b minus a. And so therefore, that's what I have. That's the length of my interval, is b minus a. And then if I find the midpoint, let's say I find the midpoint and it is, I'm not sure where the midpoint is. I know y'all you guys like to end the class, but I'm like bummed. Okay, so here's my midpoint. Let's say my midpoint occurs right here. This is C, so C is the midpoint. So C is equal to A plus B over 2, the midpoint. And I find that height. So the height of the function at that value of the midpoint. Oh boy. Okay. There's the height of the function at the midpoint. And then I'm going to take that height Okay, I'm going to take this height and take this height, and I'm going to say that that's the area, that's the area. So my approximation for the area is actually rather bad. Does everybody see how bad that is? But that's my approximation. So the area of this is to take the length, which is B minus A, and then multiply it by the height, which is F of A plus B over 2. And that gives me an approximation for the area under that curve. Okay. Let's let n equal 2. So now H, so I'm going to find that same midpoint C, wherever I found C. Here was C. I want that to be gray. Oh, that's fine. It can be black. And so now I'm dividing the interval in 2. So now this is going to be H. So now before this whole thing was H. So now H is going to go from A to C, and H is going to go from C to B. So now H is going to be B minus A over 2. Okay, so now I'm going to find midpoints. So the first midpoint is going to be here. And the second midpoint is going to be here. And now I'm going to use those. So F of the first midpoint gives me a height. Oh gosh, it won't do it. Okay, I'm going to have to draw it in myself. So on the first interval, that's the height of the midpoint. And on the second interval, that's the height of the midpoint. Okay, so now I'm going to draw a rectangle. So here's 1. So this is, I get this area now. And then I'm going to get this area. Notice it's a better approximation, right? That's better than the first one. At least I think for this one, I can see that I have too much here. So it's too much here. Well, too much here, not enough here, too much here, and not enough here. So they might kind of balance themselves out and give me a better approximation. Okay, so now as I do that, when I go to do an approximation, I now have this area and this area. Okay, so now I'm going to get half of, so I'm going to get F delta, so the area. So now what are my points? My points are, okay, let me draw a line first. That'll help me. This is A, this is B, this is B plus A over 2. This is B plus A over 4. And this is B plus A over 4 times 3. Okay, so now what do? I have to do my area. Is the first interval is B minus A over 2 plus times F of B plus A over 4. That gives me the first big block. Plus B minus A over 2 times the next big block, which is F of 3 times B plus A over 4. And so now that's an approximation. So we keep doing this until we actually get a formula where we can use in order to be able to do the midpoint rule. Okay, so on every interval, we're going to compute a midpoint. So here, this midpoint was just the first one, M1. So I'm going to call that M1. That was the midpoint. So I can write this as A is equal to B minus A times F of M1, because I only have one midpoint. Here I have one midpoint and the second midpoint. So I get A is B minus A over 2 times F of the first midpoint plus B minus A over 2 times F of the second midpoint. So I can keep doing this. So now divide the interval AB into N subintervals. Where each subinterval has a midpoint MK. So we're going to take this. So here's B minus A. Here's A and B. A, B. Divided up into N. Okay, got 1 minute. So this will be, so here will be M1. In between will be M2. In between will be M3. And this last one will be MN. So therefore, my area approximation integral from A to B of f of x dx is going to be approximated by B minus A over N times the sum K equal 1 to N of f of M Okay. Okay. So we will do one of these tomorrow. And then we will also learn the trapezoidal rule, and we will also do Simpson's rule. Phew. And I don't know if we're going to get through it all tomorrow, but we are definitely going to learn the trapezoidal rule tomorrow and finish the midpoint rule. Okay, guys.